Hello students, welcome to Interconnecting Physics. Today in this video, I will explain you how to solve the basic numerical problems based upon series and parallel combination of resistors. So without wasting time, let's get started. For regular updates, you can follow me on given links. So first of all, if you want to solve numerical problems, then you have to follow some basic steps to solve the problem. Number one, read carefully what the problem is, because most of the students don't read problem carefully and they run away from the problem. So first of all, take long breath, take deep breath and read carefully what the problem is. Then find the concept, theory, principle behind that problem. Then recall the formula which is used to solve the problem. Then write down given values with proper units. If you are given with charge, then write down that value in coulombs. If you are given with the value of resistance, then write down that value in ohms. If you are given with current, then write down that value in milliampere or ampere, whatever you are given with. Then convert all the values in the same system of units. Most of the times we solve the problems in SI system. So always convert all the values in same system of units, whether CGS or SI. Now solve the problem. This is the only way you can build confidence with numerical exercises. Now today the formula which we are going to use are: number one, if number of resistors are in series, then equivalent resistance between 2 points will be R1 plus R2 plus R3 plus up to so on Rn. And if they have same value of resistance, then we can write Rs equal to N into R, where N is the number of resistors. And if n number of resistors are parallel, then 1 over Rp equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus up to so on 1 over Rn. And if we have two resistors in parallel, then result is Rp equal to R1 R2 divided by R1 plus R2. Why? Because for two resistors we can write 1 over Rp, 1 over R1 plus 1 over R2. If we take LCM R1, R2, then result is R1 plus R2. And if 1 over Rp is this, then Rp will be R1, R2 divided by R1 plus R2. And if n number of resistors are in parallel and each resistor has same value of resistance, then we can write equivalent resistance equal to R divided by N, where N is the number of resistors which are parallel. Now, the main points which you have to remember: number one, when resistors are in series, okay, like this, 1, 2, up to so on N, okay, R1, R2, Rn. Then number one point, current is same in series combination. Current is same across each resistor in series combination. And number two, voltage gets divided. Okay. And in parallel combination, if number of resistors are parallel, 1, 2, up to so on N. Okay. 1, 2 and N. If number of resistors are parallel, then number one, current gets divided. Number two, voltage remains same. Okay, voltage same. Now, if two resistors are parallel, then voltage across them will be V1 equal to V2, because voltage is equal in parallel combination. Then according to Ohm's law, I1 R1 which is equal to I2 R2, because current gets divided. So if we have two resistors which are parallel, then I1 R1 equal to I2 R2. So let's get started with first numerical. Numerical number one, if three resistors 3 ohm, 4 ohm and 6 ohm are connected in series, this combination connected to a battery of 10 volt, what is the potential drop across each resistor? Now you know very well that in series combination, current remains same across each resistor. and potential gets divided. That means this 10 volt potential has been divided into 3 resistors. Okay, let us say V1 is divided into 3 ohm, V2 is given to 4 ohm, and V3 is given to 6 ohm. According to the relation, we know V equal to IR. So according to V equal to IR1, V2 equal to IR2, and V3 equal to IR3, because current will be same across each resistor in series combination. So voltage gets divided across each resistor according to this relation. Means that value depends upon the value of resistance. Okay. So first of all, we have to calculate the equivalent resistance in this case, because if we have to calculate V1, V2 and V3, then first of all we should know value of current. We are not given with current, and according to Ohm's law, I equal to V over R. Okay, V is given 10 ohm, but R equivalent is not given. We are given with 3 resistors. So first of all, we have to calculate the equivalent resistance, and in series combination, equivalent resistance is just sum of all the resistances, that is R1 plus R2 plus R3, which is 3 ohm plus 4 ohm plus 6 ohm, which is 13 ohm. Now current according to Ohm's law, V over R, V is 10 volt and R is 13 ohm. Both are in SI units, so result is 0.77 ampere. Ampere is the SI unit of current. Now we can calculate V1, V2, V3, because current is 0.77. R1 is 3 ohm, R2 is 4 ohm, and R3 is 6 ohm. So we can calculate the voltage across each resistor. Okay. Now numerical number 2. A parallel combination of 3 resistors takes a current of 10 ampere from 40 volt battery if two resistances are 10 ohm and 12 ohm. Find the third resistance. Okay. Let us draw the diagram first. We are given with 3 resistors which are parallel. Okay. So 1, 2 and 3. This is, let us say, R1, this is R2 and this is R3, and they are connected to 40 volt battery. Okay, plus minus 40 volt battery, and current is given 10 ampere. Okay, let us say R1 is 10 ohm, R2 is 12 ohm, and we have to calculate R3. Okay, so let us calculate R equivalent. R equivalent according to Ohm's law, V equal to IR. So R equivalent V over I. What is V? V is 40 volt. What is I? I is 10 ampere. So answer is 4 ohm. Okay. Now, if resistors are parallel, then R equivalent equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now R equivalent is 4, R1 is 10, R2 is 12, and we have to calculate R3. So we can calculate. Okay. So when we calculate, we get R3 is 15 ohm. Okay. Now numerical number 3. When two resistors are connected in series, then total resistance is 48 ohm. Let us say first resistor having resistance R1 and second resistor having resistance R2. When they are in series, answer is 48 ohm. Okay, equation number 1. Okay, so that means when they are in series, RS, R1 plus R2 is 48 ohm. When joined in parallel, sorry, this is not given. When they are joined in parallel, total resistance is 9 ohm. That is 1 over RP, which is 1 over R1 plus 1 over R2. Okay, so Rp is given 9 ohm. So 1 over 9 is equal to 1 over R1 plus 1 over R2, and this is equation number 2. Now take LCM. R1, R2, R1 plus R2. And what is R1 plus R2 according to equation number 1? It is 48 ohm. So 1 over 9 is equal to 48 divided by R1 and R2. Now we are going to use a trick, and that trick is very simple. What you have to do, calculate R2 from equation number 1, that is 48 minus R1. Okay, substitute this value here. Okay, so result will be 1 over 9 equal to 48 divided by R1 multiplied 48 minus R1. Okay, so when you cross multiply and calculate, you will get quadratic equation, which is R1 square minus 48 R1 plus 432. Okay, that is 0. Now you have to calculate roots of this equation. That is, you have to calculate the R1. Okay. Now, so R1 square minus 36 minus 12, because minus 36 minus 12 will be 48 and the multiplication will be 432. Okay. So we use factors here. So R1 minus 36, if we take common minus 12 here, so R1 minus 36. So one is 36 and another is 12. If R1 is 36, then R2 will be 12. If R2 is 36, then R1 will be 12. So that means the resistances are 36 ohm and 12 ohm. So in this way you can calculate such type of question. Two resistors are in series and you are given with value, and two resistors are in parallel, you are given with values, and you have to calculate the value of resistances. Then by this method you can calculate the value of resistances. So next numerical, a resistor of 24 ohm is bent in the form of a circle. Okay, let us suppose we have a resistor having resistance 24 ohm and that has been bent into a circle in this type. Okay, what is the resistance between the A point and B? What is the effective resistance between points A and B? Now we know total angle in the circle is 360 degree. Okay, and this line is making 60 degree angle. So 60 degree divided by 360 multiplied by total resistance, which is 24. So answer is 6 and 4. So 4 ohm. So this resistance, this one is 4 ohm, and rest 24 minus 4 ohm is 20 ohm. So that means this is 20 ohm, and this 20 ohm and 4 ohm are parallel to each other. Okay. So result will be 20 into 4 divided by 20 plus 4. Answer is 80 divided by 24, and answer is 10 by 3. So this is the equivalent resistance between point A and B, because the answer for parallel combination is R1 R2 divided by R1 plus R2. Now next numerical. Numerical number 5. A wire of resistance 24 ohm is bent in the form of a circle. What is the resistance between the points across the diameter? Means here and here we have to calculate the resistance between A and B, that is across the diameter. Now we know that resistance is rho L over A. That means if rho is constant, area of cross section is constant, then R is directly proportional to L. That means if L increases, R increases. If L decreases, R will decrease. That means when we take two sections of this circle, upper half and lower half, that means 24 ohm will be divided into 12 ohm plus 12 ohm. That is 12 ohm upper half and 12 ohm lower half of the circle. That means this resistance, upper resistance and this lower resistance, both are parallel to each other. And the result will be, if same resistors are parallel, the answer is R divided by N. So R is 12 ohm and divided by number of resistors, that is 2, answer is 6 ohm. Okay, we know that resistance is directly proportional to the length of the wire according to this equation. So along the diameter, length of the wire in both portions becomes half. So the resistance will be half, and 12 ohm upper, 12 ohm lower. So equivalent resistance will be 12 by 2, which is 6 ohm. Okay. Now next numerical, 5 resistors 10 ohm each are connected in parallel like this. 10 ohm each are connected parallel. Okay, and 3 such combinations are connected in series. 3 such combination number 1, 2 and 3 combinations are connected to parallel. What is the total resistance of the circuit? Okay, a battery of 6 volt and negligible internal resistance is connected across the network. The 6 volt battery is connected. Find the current flowing through each resistor. We have to calculate current flowing through each resistor. Now RP, what is RP? Which is R divided by N. Okay, so what is R? R is 10 and number of resistors, that is 5. So answer is 2 ohm. Here answer is 2 ohm. Here answer is 2 ohm. Here answer is 2 ohm. That means this 2 ohm, 2 ohm and 2 ohm, they are in series. So answer is 6 ohm. So total resistance, effective resistance of the circuit is 6 ohm. Now what is current? Current will be voltage divided by resistance. What is voltage? It is 6. What is resistance? That is 6. So 1 ampere. Now we know that in case of parallel combination, current gets divided, but in series, current is same. So in parallel combination, current will be divided into 5 portions. Why? Why 5 portions? Because all the resistance has same value, 10 ohm, 10 ohm, 10 ohm, 10. That means 1 ampere current will be divided into each resistor which are parallel 1 by 5 ampere. So that means 1 by 5 ampere will go to each resistor. 1 by 5 ampere will go to each resistor. Okay. And 1 ampere, here 1 ampere across the circuit. Because in series current remains same. But in parallel it gets divided into each resistor by the value 1 by 5 ampere. Okay. Now next numerical number 7. A letter A consists of uniform wire of resistance 1 ohm per centimeter. 1 ohm per centimeter. That means for 1 centimeter resistance will be 1 ohm. For 2 centimeters resistance will be 2 ohm. For 3 centimeter resistance will be 3 ohm. For 10 centimeter resistance will be 10 ohm. For 20 centimeter resistance will be 20 ohm. The sides of letter are 20 centimeter. Okay, sides like this. This is A. This is 20 centimeter. If this is A, this is C, this is E. It is also 20 centimeter. That is AC equal to AE equal to 20 centimeter. Long cross piece in the middle is 10 centimeter. This long cross piece, if this is B and this is D, this is 10 centimeter. While the apex angle is 60 degree. This angle is 60 degree. Find the resistance of the letter between the two edges. Means we have to find the resistance between point C and okay. Now this is 20 centimeter. That means resistance will be 20 ohm. Resistance will be 20 ohm. If this is 10 centimeter, resistance will be 10 ohm. And in the middle, this piece is at the middle. That means here 10 centimeter will become 10 ohm. 10 centimeter will become 10 ohm. Here 10 centimeter will become 10 ohm. Here 10 centimeter will become 10 ohm because we are given 1 ohm per centimeter. For every centimeter 1 ohm resistance will be there. Okay. So given resistance 1 centimeter equal to 1 ohm, that means 20 centimeter will be 20 ohm. So long cross piece in the middle 10 centimeter, that means its resistance will be 10 ohm. AB equal to BC and AD equal to DE and each resistance is 10 ohm. Now so you see AB and AD. AB, this BAD. These two resistances are in series and series result will be R1 plus R2, which is 10 plus 10, that is 25. Okay. So that means this equivalent circuit will be 20 ohm and this 10 ohm. B is here, D is here and A has been calculated because 10 plus 10 is 20 ohm. Now 20 ohm and 10 ohm, these two are parallel. So answer will be 20 into 10 divided by 20 plus 10. So answer is 200 divided by 30 and answer is 20 divided by 3 ohm. Now equivalent diagram will be this 10 ohm, this 20 by 3 ohm, this 10 ohm. These three are in series. So answer will be R equivalent equal to 10 plus 20 by 3 plus 10. LCM is 3. This is 30 plus 20 plus 30. Answer is 80 by 3 ohm. So equivalent resistance between two edges C and E is 80 by 3 ohm. Now next numerical number 8. Three resistors R1, R2 and R3 are connected to a battery 12 volt like this. This diagram you are given with, that is R1, R2, R3 are the resistors which are connected to 12 volt battery. This is positive, this is negative. Calculate the current across each resistor and heat produced in each of the resistor in 2 minutes. Okay. Now you see R1 and R2 are parallel. So answer will be 6 into 3 divided by 6 plus 3, which is 18 divided by 9 into 2 ohm. So equivalent diagram will be this 2 ohm and this R3 4 ohm and they are connected to some battery. Now they are in series. So answer is 4 plus 2, which is equal to 6. Now current is according to Ohm's law, V over R. V is 12 and R equivalent is 6. So answer is 2 ohm, 2 ampere. Sorry, 2 ampere. Now R1 and R2 are parallel. These are parallel. So that means potential drop across R1 is equal to potential drop across R2, because we know that in parallel combination current gets divided but voltage remains same. That means V1 equal to V2. If V1 potential is here, V2 potential, if we assume V1 is going here, V2 is going here, in parallel combination V1 is equal to V2, and according to Ohm's law I1 R1, I2 R2, because V1 is I1 R1, V2 is I2 R2. Okay, what is I1? I1 is the current across R1, and what is I2? I2 is the current across R2, because in parallel combination current gets divided. Okay, now what we have to do I2 divided by I1, which is equal to R1 divided by R2. What is R1? R1 is 6. What is R2? It is 3. That is 2. That means I2 equal to 2I1. This is equation number 1. This is the method how we calculate the current across each resistor. Okay. Now we know that I1 plus I2 will be equal to I. Let us say if I current is going through here, then it gets divided into I1 and I2, and here I1, here I2, both current will be added and will become I. Okay, so let us say I1 plus I2 is I. Okay, now equation number 2. Let us solve these two equations. Here put the value of I2 which we have calculated, I2 equal to 2I1. Okay, so when we substitute 2I1, we will get 3I1. I equal to 3I1. That means I1 equal to I divided by 3. What is I2? Which is 2I1. Okay, what is I? I is, what is I here? I is 2 ampere. Okay, so I is 2 ampere. So what will be I1? It is 2 divided by 3 ampere. What is I2? It is 2 into 2 divided by 3 ampere, which is 4 by 3 ampere. Okay, do you understand? That is this resistor, and this resistor. Okay, they are connected to some battery. Total current we have calculated 2 ampere through this circuit. So this 2 ampere, when come to this point, it will get divided into two parts. One part will be 2 by 3 ampere and another part will be 4 by 3 ampere. Okay, and here these two currents get added and will become 2 by 3 plus 4 by 3, that is 2 ampere. Okay, 2 ampere goes from here and 2 ampere will go from this resistor. That means in series combination, current is same, that is 2 ampere. 2 ampere goes from here and come back to here. But in parallel combination it gets divided. Okay, and the method here, this is the method. In this way you can calculate. Okay, now we have to calculate heat produced in each resistor. So what is I1? It is 2 by 3. What is R1? It is 6 ohm. What is T? It is 2 minutes. You will have to calculate 2 into 60, that is 120 seconds. Okay, across R2, what is I2? I2 is 4 by 3 and 4 by 3 square is 16 by 9. R2 is 3 ohm and T is 120 seconds. So answer is this. And what is I square R3T? I is 2 ampere, 2 to 4, and R3 is 2 ohm, so 2 to 4 and 2 into 60, which is 920 joule. So in this way you can calculate the heat produced across each resistor. Now numerical number 9. Determine the voltage drop across the resistor R1. In the circuit, where E equal to 60 volt. Okay, and R3, R4, R2, R1 are given here. So we have to calculate potential drop across R1. Okay, now in series combination, potential gets divided. So first of all, let us calculate the equivalent resistors. Now these two are in series, R3 and R4. What is R3? It's 5 and 10. That is, answer is 15 ohm. Okay, this 15 ohm, and R2, what is R2? This is 10 ohm. Okay, now this 15 and 10 are parallel. So answer will be 15 into 10 divided by 15 plus 10. Answer is 150 divided by 25. And answer is 30 divided by 5 ohm, which is 60 ohm. Sorry, 6 ohm. Okay, now this 6 ohm and this R1. What is R1? It is 18 ohm. These are series. These are in series. So answer will be 18 plus 6 is equal to 24. Okay. Do you understand? These two are in series. So they get added. Okay. And answer is 15 ohm. Now 15 ohm and this 10 ohm. R2 is 10 ohm. They are in parallel. So answer will be 6 ohm. And 6 ohm and this R1, that is 18 ohm, they are in series. So answer is 24 ohm. So R equivalent equal to 24 ohm. Okay. Now let us calculate the current. Current is according to Ohm's law, V over R. V is here E, and E is 60 divided by 24, and answer is 2.5 ampere. So 2.5 ampere is the total current that is flowing through this circuit. Now we have to calculate potential across R1. So that is V1 equal to IR1. What is I? It is 2.5. What is R1? It is 18. So answer is 45 volt. Okay. Now next numerical number 10. An EMF of 6.6, sorry, here 6.6 volt is connected to the combination of resistors shown below. This is the combination you are given with. What is the equivalent resistance connected across the terminal of the cell? Means here you have to calculate the equivalent resistance between A and F. What is the value of current? Now you see this 20 ohm and 10 ohm are in series, B, C, D, because this forms a chain, B, C, D. These are in series, so answer will be 20 plus 10, that is 30. So equivalent diagram will be 20 ohm, this 10 ohm and this 30 ohm. Okay. Now this 30 ohm and 10 ohm are parallel. So answer will be 30 into 10 divided by 30 plus 10. So answer is 300 divided by 40, and answer is 7.5 ohm. Now this 20 ohm and this 7.5 ohm, these are in series. Okay. So equivalent resistance between 20 plus 7.5, that is 27.5 ohm. Now next question is, what is the value of current? Okay, what is the value of current? Current will be equal to E divided by R equivalent. According to Ohm's law, V equal to IR. Okay, V equal to IR, then I is V over R. Here V is given in the form of EMF. So E divided by R equivalent. What is R equivalent? It is 27.5. What is E? It is given 6.6 ohm. So I will be 0.24 ampere. Okay. So numerical number 11. Find the total resistance of the network shown in the figure. Okay. You see this network 1, this is 2, this is 3, and this is 4. Okay. 2 ohm, 2 ohm, 3 ohm, 3 ohm, 2 ohm, 2 ohm, 3 ohm, 3 ohm. That means each unit has same value of resistances. Okay. Now you see 2 ohm and 2 ohm are in series. You see first unit. Okay. First unit is repeating every time. You see, first unit is repeating 4 times. So you see only first unit. 2 ohm plus 2 ohm is 4 ohm. 3 ohm plus 3 ohm is 6 ohm. Okay. So these two are parallel now. So answer is 4 into 6 divided by 4 plus 6, which is 24 divided by 10. Answer is 22.4. That means answer of first unit is 2.4 ohm. Answer of second unit will be 2.4 ohm. Answer of third unit will be 2.4 ohm, and answer of fourth unit will be 2.4 ohm. And total resist, and these four resistances are in series. So answer will be N into 2.4. What is N? That is 4. And 2.4, answer is 9.6 ohm. Okay. So in this way you can calculate such type of networks. If you are given with 5 networks, 6 networks, you can calculate that. Okay. So this was all about today's lecture. We are done with every type of numerical in which we have calculated resistance, voltage across each resistor, total current through the circuit, or current through each resistor. So thank you very much. Don't forget to like, share and subscribe. If you want PDF notes, you can ask me in comment section, or you can follow me on my Telegram channel. Stay happy, stay healthy.